Hello, ladies and gentlemen. Welcome to my second recording here. I was going to walk you through another example problem just to make sure we're all on the same page. I would have to solve one of these multivariable linear systems. If you go ahead and take a look at this one, there's actually number one on the paper that you're going to be doing. So if you notice, I have attached the paper with the answer key. So just like we would do them out of the book, I don't know if everybody has their book or not. So I want to make sure we all have the same access. Basically, I want you guys to try all of these, and you're going to submit them to me, and then you can check your answers as you go to make sure you're on the same page, and if not, we can look at that. But let's do number one together again, just to kind of double check and make sure we know what's going on here. So I want to solve this system. I want to solve for x, y, and z. So what I'm going to be doing is I'm going to be taking a look at using those row operations. I can either switch the order, I can add a multiple of them to each other, or I can multiply a whole row by a number to help myself out. Now, when I look at this, I actually see something nice. My y's kind of all line up to where they're easily going to cancel. In fact, I can cancel out these two very easily by adding this row to them. So what I'm actually going to do is I'm going to start by actually switching the third row and the first row. So I'm going to switch row 1 and row 3. And if you notice, I kind of write out what step I'm doing each time. It's a good way to keep your work organized, to kind of show, okay, I did this, and I did this, and I did this, and here's where I got my answer. You're going to notice that with a lot of these problems, the thing that messes you up is more the simple calculations, like the adding or subtracting, you add something wrong, and it messes your whole problem up, more than necessarily the big concept that we're doing here. So I'm going to go ahead and switch those two rows. So I'm going to put this row first. And the reason why I'm doing that is because this is going to be the row that is going to keep its y, and the other two are going to be canceled out. And I want my top row to have all three variables, and my other two to have the variables disappear. So if I'm going to be getting rid of those y's here in the next step, I want to make sure that they're going away in the second and third row as opposed to the first row where I want to have all three of my variables. So you can see I'm recopying these down, and I'm moving that top row down to the bottom. So minus 5z equals 2. All right, now that I've gone ahead and flipped those two rows around, and I can go ahead and make my next move here. I'm going to kind of move this up here so it's out of the way. And we're going to go ahead and we are going to do row 1 plus row 2 and row 1 plus row 3. So we'll do row 1 plus row 2, and then row 1 plus row 3. Again, why am I doing that? Because that is basically doing elimination. It is going to allow that y's to disappear from these two rows. 5y plus this will give me 0. So my top row is going to stay the same. I'm not touching it. It's going to stay exactly the same as it was. My next row is going to change, where I'm going to go ahead and add in each element from the top. So x plus 4x is going to be 5x. 5y, negative 5y, that will disappear and go away. Negative z and 4z will be 3z. And then negative 20 and 19 will be negative 1. And then I'll go ahead and do the same thing. I'll add this first row to this last row. X and negative x will be 0. Oh, that's kind of interesting. So I kind of actually got a 2 for 1 in this situation where the x cancel out as well as the y canceling out. Now you're going to see that's going to be very favorable for us here in a moment. Negative z and minus 5z, add those together, I get negative 6z. And then negative 20 and 2 will be negative 18. And luckily for me, with these two moves, I now have a back substitution system. I have one variable in the third equation, two in the second equation, and 3 in the first equation. Meaning that I now can solve for z, plug it in here, solve for x, plug it in here, solve for y. So solving for z, I'll divide by negative 6. I'm going to get that z equals 3. I can go ahead and plug that in here, so I get that 5x plus 3 times 3 equals negative 1. If I do 3 times 3, I get 9. Subtract that, I'll get 5x equals negative 10, which means that x will equal negative 2. Now we're not done yet. We have our x and we have our z. We need to solve for y, so we'll plug these both back into the first equation. So we'll have negative 2 plus 5y, that is a 5, minus 3 equals negative 20. And if we add these together, we'll get negative 5. Add that over, get negative 15. We're going to end up with y equals negative 3. And so my final answer wouldn't be all these three separate. I want to write it as that point in 3D space, which would be negative 2, negative 3, and 3. Thank you guys again for watching. Hopefully this was, again, kind of give you a little bit of an idea of what we're doing here. Feel free to email me any questions you have as you're working through this assignment. Thank you.